Well, hello. Today we're talking about the remainder and factor theorems. This is pretty easy, so hopefully you'll find it easy as well. So let's start. The first thing we're going to talk about is the remainder theorem. The remainder theorem says if you take a polynomial and you divide it by a binomial, usually a binomial, but it could be a polynomial. It kind of depends. But if I divide by a number, in this case q minus r, I'm going to have, I could do like synthetic division, so r would be the number in the box, or I could do long division, where I'm dividing by x minus r. If that happens, then the remainder is a constant. So just like in my example here, I have x squared plus 6x plus 2. If I put 4 in the box and do long division, I would end up with x plus 10 as my answer, and then 42 is my remainder. The 42 would be, in the past, we had taken 42 and put it over x squared plus 6x plus, nope, I would put 42 over x minus 4, but we're not doing that right now. We're just saying that our remainder is 42, just some number. So for here, I want to find f of 6. So there are two basic methods that I can do that. One method is by synthetic substitution. So when I do synthetic substitution, what I'm going to do is I'm going to put the number that I'm evaluating. So in this case, I am evaluating 6. So I'm going to put 6 into the box. And I'm going to do synthetic division. So I would bring down the 2. I would put a 0 in because I have no coefficient for my x cubed. I would bring down the -5, the 8, and the -7. From there, I'm going to follow the procedures for synthetic division. So I would have the 2, multiply 2 times 6 to get 12, bring down the 12, multiply 6 times 12, which is 72, add down to get 67, then multiply, then add, then multiply, and then add. When this happens, I end up with 2,453. My remainder is going to be the plain number. When I have that, this case, it was 2,453. That should be the same thing you get if you were to substitute 6 into the equation. So that's why they call it synthetic substitution. So here, I'm going to actually try it. So go ahead on the next slide. You can see that I substitute 6 in place of x. So if I substitute 6 in place of x, I would have 2 times 6 to the 4th minus 5 times 6 squared plus 8 times 6 minus 7. When I do that, I get 2,453, which is the same remainder I got. So that's telling me that when I evaluate a function, it's the same thing as the remainder. If I were to divide by, say, in this case, x minus 6. Pretty cool. I don't know who had so much time to figure that out, but it is pretty neat. So go ahead and try a problem, and then I'll be right back. So now comes your favorite part of the lesson. We're going to do word problems. But you know what? These word problems are not that bad at all. So here we are with our word problem. And of course, you're going to have to read it. So I'll pause for a second for you to do that. So they want us to find out how many college students we're going to have in 2011. They tell us that X is the number of years since 1993, and I'm in the year 2011. So the first thing I need to figure out is how many years are there from 2011 to 1993. So I subtract. When I subtract, I find out that there are 18 years. So that's why 18 is in the box. Then I'm going to use all of the coefficients. So I have 0.02, negative 0.52, 4.03, 0.09, and 77.4. I'm going to evaluate it, and I'm going to do using synthetic substitution. So that's why the 18 is in the box. I'm going to follow the procedures for synthetic division. When I do that, my remainder is what I would have gotten had I substitute in 18, which is the years 18 years from 1993. So when I do that, I get 451.76. Now that tells me that it's 451.76 thousand students. So since it's in thousands of students, I do kind of need to convert that from what I have to thousands of students. So that's 451,000, and then 0.76 means 760 students. So then you would need to make sure that you rewrite that so that it's in the proper format based on the fact that that is thousands. So try the next problem. It should be relatively easy. As word problems go, there's really not that much you have to figure out. You're just using synthetic substitution. I'm saying synthetic substitution. I mean, I guess if you wanted to, you could do direct substitution and just substitute the 18 in. In case you're wondering, the benefit in synthetic substitution, I find that synthetic substitution causes less sign errors because you're able to copy down the signs as you write the coefficients for all of your terms. So I like synthetic substitution a little bit better. It alleviates some of those sign errors, which I know end up causing a little bit of a problem. Other than that, that's about the basic idea of doing it. It has a little less work. It's a little more showing of work, but that allows you to show your work in case you need partial credit. All right, give it a try. See what you find. So our last little bit is the factor theorem. And the factor theorem says that if I have a binomial, x minus r, it's a factor of a polynomial if and only if it divides evenly. In other words, if my remainder is 0. This should make sense to you. For example, if I have a number, say like 24, if I have a number, say like 2, it would be a factor if 2 divides evenly into 24, which it does, as opposed to something like 7. 7 is not a factor of 24 because it doesn't divide evenly. Just like if I had a polynomial, if a polynomial divides evenly, then that means it's a factor. If not, then that means it's not a factor. So it's the same basic idea with polynomials as it is with regular numbers. So here's my polynomial. The polynomial I have is x to the third plus 4x squared minus 15x minus 15. I want to find out if x minus 3 is a factor. So if it's a factor, that means my remainder is 0. So therefore, I'm going to do synthetic division. I guess you could do long division too, but I think that would take longer. So I'm going to put 3 into the box because that would be what I would do if I'm doing synthetic division. And then I would have my coefficients of 1, 4, and negative 15, and negative 18. And then I would follow the procedure for doing synthetic division. So bring down the 1, multiply by 3, add, then bring down, and then multiply, and then add, and then bring down, and multiply and add, and I get 0. So since I get 0, that means my remainder is 0. So that means the thing that I divided by, which was x minus 3, is actually a factor. Then I'm going to look at the depressed polynomial. When I say depressed polynomial, I don't mean it's sad. I mean the depressed polynomial because the degree of the polynomial is 1 less than what I started with. So since I started with an x cubed, now I have this polynomial here, which is x squared plus 7x plus 6. So I'm going to see if I can factor, or if I could find another factor of x squared plus 7x plus 6 to factor the depressed polynomial. So when I do that, I look and I see, hey, look at that. X squared plus 7x plus 6 can factor, and that factors into x plus 6 times x plus 1. So that means that when I started with my original polynomial, since this depressed polynomial can factor into x squared, x plus 6, and x plus 1, if I put the x minus 3 with it, I have now factored that that cubic equation. So since I have factored that cubic equation, that means x cubed plus 4x squared minus 15x minus 18 can actually be factored into x minus 3 times x plus 6 times x plus 1. So now we're getting into the point where you're going to be able to factor just about anything. Right now, we have to be given a factor to find out whether or not it would work. But as we go along in the next couple lessons, you'll be able to figure out what numbers might be factors, and then go from there so that you can factor just about any polynomial. Well, or at least try to factor just about any polynomial. So there you have it. That's the remainder and the factor theorems. Relatively easy. Hopefully you found that as well. Give a try to the Google form, and I will see you in class. Good night.